Well, good afternoon, everyone. My clock shows it's 12:29, so I'm going to begin with just a couple brief comments, and then we'll move on to the presentation, be respectful of everyone's time. First thing I would like to do is thank all of you. Actually, the response to this program has been, frankly, pretty overwhelming. Uh, with all of the challenges going on in the world right now with coronavirus, COVID-19, putting on educational programming has been a bit more challenging, and so we elected this year to offer this as a virtual event with very little idea of how well this might go over. Uh, the last I checked, we've had somewheres in the neighborhood of 200 registrants from at least 20 states, as well as international interest from Canada, Mexico, Brazil, Australia, and South Africa. So we are extremely gratified for the response that we've received, and we certainly hope that what we're offering is going to exceed your expectations and help you with your business or with the clientele you work with. As you saw earlier on the um, slides that were scrolling, I also want to make a special thanks to people that helped sponsor this. That would be CHS Nutrition, Dakota Land Feeds, and Zoetis. And I know at least some of the individuals from those firms are joining with us today. We really appreciate their support, not only for this event, but for all of the events that we've been putting on to help the beef industry in South Dakota and the region, and the assistance they provided SDSU and SDSU Extension. So, and uh, the screens, the slideshow we were showing earlier outlined how to interact with us in terms of the chat room, the Q&A room in terms of asking questions. We'll have an opportunity as we wrap this program up to do that. I'd like to thank Lindsay Gerard, our tech coordinator. Uh, I got the title wrong, I'm sure, but she does an amazing job of uh, organizing these events and really helping us troubleshoot and deliver that. So without further ado, I will switch over to the slideshow and share screen. Okay, hold on just one moment. All right. Someone wants to say something, put something in the chat just to make sure or that that we are sharing the correct screen, and then I will move forward. Okay, thank you very much. Sometimes these screens, as much as we practice it, sometimes they don't always work like we would want them to. So we'll move forward and get started. And the reason I selected bunk management as the first topic of the program was because, in a lot of ways, this is really the key function of what we're doing in the feedlot. Marketing plans are really driven by some expectation of when the cattle are going to be finished and what they're going to weigh and what our costs are going to be going forward. All of the things we're going to talk about through the rest of this seminar in terms of facilities, environment, health management, and so forth can all be undone if we don't do an excellent job of delivering feed in the right way at the right time to the right set of cattle. So we're going to start here and then branch off into the other areas as we move forward with the rest of this short course. I have shamelessly stole this slide from Dr. Dan Loy, who spoke at our short course on this topic 2 years ago, because I thought it really did a super job of in capturing successful feedlot management, and it revolves around consistency, doing the same thing the same way, the right way every day. And that goes from the bunk reading, the daily inspection of the cattle in the facilities by riding or walking through them, how well we do feed deliveries and feed mixing, what are our protocols as far as animal health, receiving, etc., and are those protocols written down so that everyone's on the same page? Those things really capture what we're trying to do and what it takes in order to be successful in this business. One of the concepts that I think is important and that I really try to it really drives the discussion on bunk management or nutrition in general in feedlot cattle is this cartoon that I developed, where on one hand, on the left, if we increase intake, we'll improve efficiency, improve out weights, all of those kinds of things that are really important. On the other hand, if we do too much too soon, we open up the door to digestive upsets, acidosis, poor performance. So our real task in all of this is now, how do we balance these two elements? And this example is one I took from a publication that I found written by Gibb and McAllister, just on the whole topic of feed intake and feeding behavior, where in their example that if we have a 900-pound steer and we're able to increase dry matter intake by 10%, at least using the nutrient requirement values that have been carefully calculated, that amount of feed intake on a typical finishing diet should increase average daily gain by almost 18%. Not and slightly less than a 5% improvement in feed efficiency and in cost of gain. And so, if our cost of gain is approximately 80 cents a pound, with all of those factors figured in, if we can improve it by 4.6%, that's approximately $28 on a 700 pounds of feedlot gain that we might be putting on those cattle. And in a lot of cases, that $25, $26 might be the difference between profit and loss. So it really highlights the importance and why there's so much focus on getting cattle to eat. On the other hand, the costs, if we go the other direction and make a mistake, are things, some of the acidosis and digestive upset risk. The first, maybe what people think of first is those bloats and late period digestive disorder death loss, but it also can manifest itself in things like founder or simply cattle that just don't want to eat. That, we might call them burnt out or staled out. Cattle that don't grow as well, are less efficient. And the other part of that we don't necessarily observe while these cattle are on our feedlot facilities, but certainly is an issue from the industry, is liver abscesses. Now, we can have a philosophical discussion on whether these costs are more or less than the costs we might impose due to fear of causing acidosis and digestive risk, but they are real. And if we do make a mistake, excuse me, if we do go too far, we do run the risk of some of these production losses. So there's kind of the balancing point of the two. The other challenge, we're dealing with an animal that first off, these effects that happen on an individual animal basis, but we measure intake based on pen. So we can't really tell that individual animal variation. And so we have to try to manage the animals as a group. The other challenge is if we're not careful and if we allow too much variation or allow the animal to make too many choices, we've essentially, I've seen it described as, we have hired the steer to be a feedlot nutritionist, and they're not very good at that job. So what we have to do is try to manage animal behavior to nudge cattle to eat as a group, to improve the consistency of dry matter intake and allow them less opportunities to sort or to make their own decisions, and also reduce feed waste. As we know, wasted feed still costs us money and still affects the bottom line. Another cartoon sort of showing the perhaps the risk factors that might depend on what we're feeding those. And this is from, I'm sure this has been, most people have seen this particular graph or something very much like it, written by Stock and Britton, where some of the feedstuffs that we may use, things like wheat or barley or high moisture corn, have a much greater degree of starch degradability compared to things like dry rolled corn or whole corn. So what feeds we're using also influences some of our decisions we have in that balance point that we talked about earlier. So now after we've kind of maybe set the table as to why this topic is important, now we're going to discuss some of the research that's been done comparing controlled feeding versus ad lib. Yeah, if we were presenting this program 25 years ago or so, that ad lib, essentially we just keep the bunks full strategy was relatively common. And this is one example of some of the research that was done that helped challenge that. And there's certainly others, Dr. Gallian and others, workers across the country did some of that pioneering work to shed some light on controlling intake. This was some work done here at South Dakota State University on a set of yearling steers where half of the group were fed so that the bunks would be slick most mornings, where the other half, the objective was to try to have feed in front of those cattle all the time. From a absolute final out weight and hot carcass weight, there really was no differences in any of those parameters. However, those cattle that were fed with the bunks full ate more and had poorer feed efficiency, considerably poorer compared to the cattle that were slick bunks. And interestingly enough, that's even with those cattle still had almost 4 days out of 10 where the ad lib cattle were sick or were slick rather. So this was some of the early work that said, by controlling intake, we may be able to improve efficiency without uh, negatively affecting performance. But one of the challenges then is, we ask sometimes then, well, why would that work? What are some of the reasons why? And, there have been various theories put forward. It could be that we reduce bunk sorting, we reduce the amount of waste, intakes are more consistent, or we've done things to change behavior, to change eating intensity, ask those cattle to eat more quickly, or maybe it's some effect of a slight limitation in feed intake that might be responsible for those improvements in efficiency. The challenge from a science standpoint is when we try to isolate some of those factors one at a time, a lot of times we end up with results that show no effect. There was some research just published from Ohio State where the varied feeding time with no effect on performance or feed efficiency. Uh, you know, our speaker in 2 weeks, and someone we'll be referencing is a few slides into this presentation, Dr. Alfredo Di Costanzo at the University of Minnesota. He and his grad students did some work where they monitored dry matter content of ingredients on a daily or a less frequent basis, and they weren't able to find any differences. And from a scientific standpoint, you'd look at that and go, well, that just doesn't make sense. We should be able to prove that that has an effect because intuitively we think it would. And what I think might be happening is while some of these research work, we change one variable but we tightly control everything else. And what we're really need to think about is thinking about the feedlot as a system. And I drew this up as an example of some of the factors that might influence what our target feed delivery might be. And they're by no means the only ones. We could probably sit around a group and come up with another half a dozen. And all of these things what I think is by trying to control as many of those variables as possible, we're building in resiliency into the system to keep variation at a low enough level that the cattle can adapt to it. So when we try to isolate things one at a time, the cattle are able to adapt and really not show significant decreases in performance. But when 2 or 3 or 4 of these start to get out of whack, even maybe by just a bit, now we start seeing some real issues with performance variation, and the cattle then start telling us that the system isn't functioning well. So in all of this, I don't want to leave the impression by referencing a couple of those research studies where this didn't have an effect as saying, well, time of feeding doesn't matter. That's not the message I want to pass along. The message I do want to pass along is controlling variation in all of its forms is important because it allows for the possibility that if things aren't completely controlled, we aren't going to completely fall out of bounds. So how do we control variation? Well, we need to be able to have some kind of system to describe it and measure it and react to it. So we need to develop a language system that lets us describe and measure what we observe. We need to know what the actual goal is in terms of what is the target we're aiming at, and then develop some systems, procedures, and rules to guide actions, to guide management decisions based on what we observed, and then some method to track what we have done in the past and how the system or the cattle have reacted to our changes. This is, it's been often referred to as the SDSU bunk scoring system that Dr. Pritchard had published several years ago. It's one tool that's useful as a language to help us describe what we're observing. And it's a numerical system where a 0 is, or a slick bunk is no feed remaining in the bunk. A half bunk score might be a scattered amount of feed present, but most of that bottom bunk is exposed. Bunk score of a 1 is just simply a thin uniform layer of feed across the bottom of the bunk that's usually about 1 kernel deep. And then as more feed is left over, the numerical score is increased up to a 4, where essentially those cattle have not touched the feed yet. These are some picture examples of what I tried to describe verbally. The picture on the left would be an example of a bunk score 0. Picture on the right would be of somewhere around a half. Excuse me. Then on this slide, here we have a picture of a bunk score of a 1. It might be slightly hard to see on your screen, but if you look closely in the bottom of that bunk, you can see a little bit of the concrete. So that, it's fairly clear. That's a fairly thin layer of feed on that. Where the bunk score on the right, call that a bunk score 2 plus. You can see some evidence the crown is still there, some evidence that those cattle have left a significant portion of their daily ration still in the bunk that they haven't consumed yet. So some of the ways that we would then use bunk scores is we want to check bunks at the same time every day, or certainly as near as possible, because one of the keys of this is to try to create a system where the cattle are being fed at the same time. And so then we do the bunk score and make our adjustments at the same time relative to feeding each day. We need to have some kind of record of what we've done in the past in terms of feed delivered and the amount of, and what the bunk scores were. And then we use that information along with what we see this morning and along as with the cattle behavior to determine what today's feeding deliveries are. Our response to that bunk score is something that needs to be determined with the nutritionist, the cattle manager or owner, the people that are doing the bunk reading and the feeding, to have some guidelines for how we respond to those changes. How often are we going to be increasing feed deliveries? How large will those feed deliveries be? And what is our procedure going to be if we need to cut cattle back because we've overshot or we've had some environmental issues, rain, etc., that have changed how much the feed cattle are eating, and how do we adjust for those? Those are all things that need to be determined. That's where the art of this art and science comes into play. As I alluded to, the records are really a key part of that. And there are a number of systems out there, that use technology and iPads or smartphone technology or any of varying things that will help automate some of this process and provide a faster feedback loop between the bunk reader and the cattle manager and all of the people that are involved. Those can be awfully useful, but we can also do an awful lot with a pad of paper and a clipboard. But we need at least 4 days and preferably much more than that. But one of the things that we need to be keeping a record of is what the bunk scores were in the past. How much feed did we deliver? How many days have this pen of cattle been on feed? Not everyone, the people that might be reading the bunks, perhaps we've had some turnover or change in responsibilities, or just the fact that our memories aren't as good perhaps as we'd like them to be. And we may have forgotten just how long a pen of cattle have been on feed and what diet they've been on. Our protocol may call for differing bumps rather, on a backgrounding diet compared to cattle that are on the top finishing diet. Some estimation of what they weigh so we can start thinking about where they might be in terms of their maximum intake. Then also, where have those cattle been in the past? Is this a pen that we've challenged before and found out they couldn't go that high? Or is this a pen of cattle that we are still climbing the intake ladder and that we may have some opportunity to increase their feed intake? And finally, also, if there have been any kind of out of the ordinary events where bunks had to either be cleaned, or if we've had some mechanical breakdowns or things that caused some changes in what was otherwise a predictable system. So the how much and how often, I'm not going to, I'm going to give some general recommendations, but they are just that, general recommendations that you should probably need to be talking with your nutritionist and figure out if they in fact fit in your operation or for your clientele. But in general, most of the recommendations that I see people using are somewhere between a half to 1 pound of dry matter per head per day is an increase. In some cases, maybe that may be expressed as a percentage, perhaps 5%. Typically, we don't. People recommend not more often than every 3 days. If we try to be more aggressive than that, we may have cattle that can tolerate that for a day or two, but not for the third day, and we run the risk of overshooting those. The lower energy, lower starch diets, something that we may find in a backgrounding system, are less risky, and so perhaps we can be more aggressive on some of those cattle. But we do have to be more cautious when we've got a set of cattle that are at or near their expected peak intake, or at or near their harvest weight, that they may be at the point where increasing feed beyond where they're at now might not be warranted. And the final thought I think I want to leave with you on this, in terms of how much and how often, there's a reason why greed was listed as one of the 7 deadly sins. And so we do run the risk of pushing too hard too fast and then paying for it in terms of compromised performance or poor feed efficiency as we've overshot a pen of cattle. The other part of this that again comes into the art part of feeding cattle is reading cattle behavior. That can be a critical clue as we think about whether or not to increase deliveries. How many cattle are waiting at the bunk in the morning? Do they appear hungry, or they appear content? Or is this a pen where all of the cattle are laying down and are paying absolutely no attention to the feed truck? That's probably an indication that we are at maximum intake, and perhaps even beyond. Where if we've got a situation where a few of the cattle are coming to the bunk, a few others are resting, we might be right at the sweet spot in terms of intake for that pen on that given day. Also look at consideration of what the manure looks like. If we've got a lot of really gray colored, very runny, more liquid type, not really a manure pat, but just fecal material that's more like water, that's a pretty good indication that we may have some acidosis issues going on, where perhaps we need to be more cautious in terms of how much feed we might be increasing on this set of cattle. In my opinion anyway, where the challenge and the hard part comes in is when we start dealing with environmental stress. Here in South Dakota, we're blessed with X number, seemingly some years of endless months of winter, followed by 3 weeks of spring, and then right into hot and humid. And that can really be a challenge in terms of determining how much to feed cattle and when. A typical response to heat stress is that cattle will reduce feed intake. The tough part, especially in bigger cattle, is it can be really difficult to bring those cattle back. Some of the management things we can do is if we shift feed deliveries to the afternoon or early evening, that helps from a standpoint of shifting feed to when those cattle are more apt to eat, also shifting the heat of metabolism to what we hope would be the cooler part of the day. I'm going to talk a little bit more on the next slide about, perhaps this is the environment to more tightly regulate feed increases. Cold stress, on the other hand, while it's usually more challenging for the caretakers of the cattle, from the cattle standpoint, they really handle our cold temperatures much more readily, especially if we can do some things to mitigate cold stress like bedding or providing some wind breaks. Oftentimes, the typical response then to cold stress is cattle that will want to eat more. So in those cases, that may be the place where we could be a bit more aggressive with feed calls. I'm going to spend a little time on this slide because there's a lot of information here. It's very recent data. In fact, Dr. DiCostanzo sent me the slides at about 1 o'clock this morning, and I was able to put those in because I think they show us some things. These are pens of cattle that were on feed this summer. The chart on the right was from here at SDSU. Those cattle, the blue arrow shows that a period of time, the mid-June, when we had some heat stress issues. That would also correspond to the same period of time as that leftmost blue bar that says heat for the University of Minnesota data. So in the above, and this is, I thank Dr. Smith and Dr. DiCostanzo for sharing this data with me and sharing their insights of what was going on. The chart on the right from SDSU, uh, the feedlot manager, Paul Schlobaum, was very tightly controlling feed deliveries on these pens of cattle heading into the heat, almost to the point of limit feeding them, where if there were bunk scores of a half, those cattle were getting pulled back just a bit to try to, before the forecasted hot weather. And as you can see on that chart, when we got the heat event, we saw a decline, but it wasn't catastrophic. It was a couple pounds of feed intake from the peak, which is also corresponding. These cattle were big. I think their outweight was approximately 1,500 pounds. So these are big cattle that were near done, but they were able to maintain feed intake relatively closely. The charts on the right were from the University of Minnesota, and this is intake charts from two different pens. So this isn't a composite of their whole experimental farm, just from two individual pens. As Dr. DiCostanzo shared with me, they were more tightly controlling feed deliveries during the first heat event, but on the second heat event, the degree of control was not as tight. The blue bar represents daily dry matter intake. These pens took the first heat bout relatively well, but in the second heat bout, intakes declined, and they intake particularly deep declines on the pen on the bottom right, where those cattle dropped a considerable amount of feed. And as you can tell, they haven't completely recovered yet. Now, this isn't some kind of, I don't want anyone to misinterpret this as a comparison of one university versus another. We have something very similar at our facility at Southeast Research Farm, where a group of cattle that they handled the first heat bout really well, didn't handle the second bout. Also, the SDSU cattle in this study only dealt with one round of heat, and they didn't deal with the second. So we can't assume that they would have handled it just as well. But what I think that does do, especially for those of us perhaps in the Western Corn Belt or any area where we have to deal with widely varying temperature conditions, and going from what we get a few weeks of nice weather, and then we end up with hot and high risk of hot and humid in a very short order. This might offer some clues as some ways to manage feed intake on cattle to avoid some of these deep crashes. Before as we sort of try to wrap up bunk scoring, the other part of that is, what is the ideal bunk score? For a lot of people have been told that the ideal should be a 0. This is some work it's unpublished data that was done by Dr. Pritchard, along with two of his PhD students, Wes Gentry and Ethan Blum, where they took a group of cattle, divided them in half. One half, Paul Schlobaum made the bunk calls with a target of 0, and the other half, Dr. Gentry and Dr. Blum made the bunk calls targeting a half to a 1 to try to answer the question of what happens when we target a slick bunk strategy. What does that do to overall performance and feed intake? So this chart shows the feed intake for those two groups of cattle, our average feed intake. The blue line were the cattle that were fed to slick bunk. The orangish line were the ones that were allowed just a little bit more feed. And as you can tell, they ate more. Their feed intakes were higher. And these lines represent intake after the refusals were taken out. So what this not showing is the fact that those cattle that were offered more feed, those bunks also had to be scooped a bit more often. We had more feed that they refused to eat. From a performance standpoint, the cattle that were fed just a little bit more, as we showed earlier, they ate more. They also gained more and had heavier hot carcass weight and final body weight. Feed efficiency difference were, from a statistical standpoint, were not different. However, the cattle that were slick bunk, that figures out to be a 1% improvement in feed efficiency. And also it meant that those cattle that were fed just a little bit more aggressively required just a little bit more labor in terms of they had to scoop some feed bunks. So from that standpoint, this gives some indication of back to that point about balance. of what the effect some of our decisions might be. Now, I'm not here trying to present that one of these approaches is superior to the other, but more of a trying to illustrate how we might be able to influence outweights, feed efficiencies, and so some of the things that you might have to deal with in your operation in terms of business models, labor supply, and so forth might drive that decision. The other point on that is from a complexity standpoint, though, by increasing the feed intake deliveries by just a little bit, does increase the complexity of operating a feedlot. Because now we have to start thinking about when we have some leftover feed, what do we do with it? If we need to reduce feed deliveries, how much do we deliver that? And do we run the risk of overshooting by reducing deliveries and then starting cattle out on some kind of yo-yo pattern? So that's something that I think needs to be considered as we're evaluating what our target uh, bunk score might be. Another example of a similar kind of concept that was done at the New Mexico State University at their Clayton Research Center, again with yearling steers, where they used two different bunk management strategies. The slick strategy was their target was to have slick bunks in the morning and about half a pound of feed left at 10:30 at night. The other strategy was they wanted about half a pound of feed at 7 o'clock in the morning. In this particular study, they didn't put a bunk score on in terms of what their objective was, but my interpretation of a half a pound per head would be somewhere between a 0.5 and a 1, much like what the SDSU research had showed. On the table on the right shows what the results of their study and what they observed. In both groups, the slick bunk by design was slick about approximately 2/3 of the time, where the treatment where they were a bit more aggressive in terms of feed delivery were slick about 20% of the time. Dry matter intake, as you'd expect, was higher with the with the more aggressive feed deliveries. If you look at the difference between the dry matter intakes and the dry matter intake with refusals, you can see that they, with the slick cattle, there were some amount of refusals or waybacks, but it was fairly low, a bit more in terms of the cattle that were offered more feed. Average daily gain really wasn't different. Feed to gain, in you thinking of this in a real world situation where the feed that was refused still needs to be paid for, the slick bunk strategy was more efficient. In this study, they showed an improvement or an increase rather in hot carcass weight, also an increase in marbling score with cattle that were offered more feed, agreeing with some of what was done at South Dakota State, where by offering more feed, it enhanced performance a bit compared to the more slick, more tightly regulated group of cattle. So now we're going to, one of the challenges with this setting is that it doesn't always allow as much interactivity or as much opportunity for people to engage. So when I was designing this, I wanted to offer some opportunity for you folks to participate. So I've come up with 3 different scenarios, and Lindsay's going to activate the polling feature. And so we're going to give you a chance to make the feed call for today on a particular pen. Our first pen has 900-pound steers. They've been on feed for 30 days. We're on our final diet, and you can see on the table that on day 1 we had just bumped them up by half a pound. They'd left a little bit of feed on day 2, but now we've had 3 days in a row of a 0. We've been feeding them 19.5 pounds per day. So now it's your turn. What is the opinion of how much we ought to feed that group of cattle? And we'll let the polling go for just a little bit more. Till we give everyone a chance to answer. I'm going to go just a couple more seconds, then we'll close. Give you 5 more seconds. Okay, I'm going to close the polling. And this isn't a case of where there's an absolute right answer, but it looks like the general consensus of the group of us on here is that these cattle are ready for another half a pound bump. Got some numbers that say maybe we ought to keep them the same, and some others that are a bit more aggressive. But that's when I was designing that. That's kind of what I had in mind is might be the appropriate spot. So now we'll move on to number two. This is the bunk scores were the same. The pattern of feed deliveries is the same. The only difference is these cattle are bigger, been on feed longer. These are 1,300-pound steers, been on feed for 120 days. We've had 3 days at 27 with 3 days in a row of 0. What do you folks think in terms of feed deliveries? We'll go about 10 more seconds and then close. Okay, looks like we're done. Looks like as a group, we're thinking these cattle are at or near their peak, and we're going to, as a group, the plurality says we're going to bump these up a quarter, but we got a significant number that are thinking, well, maybe we can go half, and some others that are thinking we need to hold those at 27 for one more day. Final, I threw one last wrinkle in. This is the same feed, same scenario, same set of cattle, except now we know what the weather forecast is going to do. And it's going to get hot. It's going to be hot and humid. We got significant heat stress in the forecast. So how does that change what you think we might need to do with this pen of cattle? Okay, we're gonna close it out because we're at about the same percentage we were before, but you can sort of see it becomes less simple as we start throwing heat and weather in as to how we want to do this. We've got a similar kind of pattern where plurality of you folks are thinking we're going to back these cattle down. Um, it's be curious if I'd done this before I showed the University of Minnesota and SDSU slides or after what our answers might have been. But I think that set of data certainly supports that kind of conclusion that those cattle might be ripe for a pullback, or at very least, I could say no one's looking at increasing feed because it's certainly possible that that might be a mistake. All right, so now I'm going to shift gears and we're going to start talking about where can things go wrong. So far, we've talked about bunk scores and using that information to guide feed deliveries. Now we're going to talk about some of the other things that might create more variation, create more chances for errors and for things to go wrong. So first thing I talked about was mixing errors, and I polled some people. I've polled various people across the industry on what they see, and almost universally, the first thing they talk about is overfilled mixers. I'm not sure, and coming from a production background myself, I think part of it is like, you know, I know if I stuff just a little more in, I can save a trip and save a lot of time, so let's do it. Or it's, well, I can afford this big of a mixer, but I really need to feed more feed than that, so yeah, it'll work. But uh, all mixers need some room for feed to fall in order for the mixing process to work. And by and large, most of them, when we get to about 80% of capacity, that's really where we need to be thinking about stopping. So from a capacity standpoint, we need to be sizing equipment based on the size of loads we need to deliver. And once we have that, we really don't want to be trying to violate those rules in terms of trying to stuff more feed in because it's just not going to work well. The other part that folks will mention to me is a challenge is worn out equipment. And an evidence of that is if simply if the feed wagon won't clean out. either under the whether it's vertical or horizontal. If there's evidence of feed left, at some point, some of those wear parts simply start to wear out, and we either need to rebuild it, replace the parts, rebuild the equipment, or trade it off for something that is going to work. But those are a couple sources of error that I see from a mixing standpoint. I would have liked to have told you that I could present you a recipe that's going to work in all systems in terms of mix order, mixing time for all different kinds of diets and all different kinds of equipment. And every time I try to look up the data that would support one or the other, I fail. There just doesn't seem to be. It is so dependent on what people are doing on an individual operation, what their feedstuffs are. So this is the case where, for those of you that are working with nutritionists, this is an opportunity for them to use that expertise and use some tools that we'll talk about in just a bit in order to determine what you need to do in your operation and then stick with it. Some of the rules that, or concepts that get talked about is that like mixes with like really well. So a dry supplement and dry grain, those feedstuffs mix well together. So they should probably be together in terms of the mixing order rather. Ground hay is a challenge because it's very variable in terms of particle size, density, and so forth. Wet sticky feeds can be a real challenge, and it seems to be that the general consensus is some of those feeds generally should be later in the mixing order. But again, don't take my word for it. Work with the professionals that are working with your operation to determine what works with your equipment and your diets. We have some ways to measure some of that. I've got a picture here of the Penn State particle separator that I know a number of folks use as a way to determine from a particle size standpoint how much variation there is in the load. Some different lab analysis that we could use. If we're feeding ionophores, that's probably the gold standard because the ionophore is only going to be found in the supplement. So if there's any variation within a load, we know it's because of variation in how well the supplement got mixed. Some of the other components may work depending on what's in our diet. If we're including two feeds that are similar in ADF content, for instance, that's not going to be a good marker because we won't be able to tell where the ADF is coming from. Same with dry matter. If we're using only one wet feed, dry matter might work as a way to measure variation, but it's not going to work well if we're feeding, say, wet distillers and silage together. But generally, we want the coefficient of variation as small as possible, 10% or even less. The coefficient of variation, that's the standard deviation divided by the mean times 100%. Again, talk to your nutritionist and work with them to determine how we want to try to minimize that. In my opinion, if I were building a feedlot now, I would certainly consider having some kind of sheltered mixing area. At least living here in South Dakota or in the plains where the wind blows all the time gives us the opportunity to cut down on wind loss of feed ingredients, wind-induced scale errors, shelter from precipitation, and if we pour some concrete, we can get out of the mud. Scale error, I think this is an area where happens more than we recognize, because we assume that digital scale, by reading out to the nearest pound, 2 pounds or 5 or whatever our readout is, we assume that's accurate because there's an exact number there. Problem is, it's simply an electronic instrument. So if there's issues with the monitor, we've got some cables that are loose or the mice have gotten in them. If we have wind that's blowing our scale around, or if we've got to be taking equipment over rough roads, or we're dealing with some uneven surfaces, that can introduce some errors into the scale. The picture I've got is of our Southeast Research Farm, where they've been putting some amendments out into the lot to try to improve drainage and make the feeding surface more desirable and work better in our environment. But they're also putting some of that to fill in some of the low spots in the feed alleys that develop over time. So one of the things that we could do that I don't think is done often, but may really pay off, is take the feed wagon, if you've got access to a truck scale that's close, that's calibrated, perhaps a local elevator, fill up the feed wagon with feed, and then come back and feed that out and see if the two scale measurements match up. I won't talk a lot about dry matter monitoring because I want to make sure we leave enough time for questions. This was some data provided to me by Dr. DiCostanzo. The orange triangles show how much dry matter content varied over time in ground hay, and it looks like a scatter plot. This was taken during the spring of the year, an uncovered hay pile, so lots of precipitation events, wide swings and variation. What they found though is that dry matter um, didn't necessarily affect performance as much as we would have expected because the inclusion rate was fairly low, and they were able to successfully feed cattle even though they were had some fair amount of variation. My point of view, I think, in terms of managing dry matter variation is to try to prevent it in the first place. Whether or not that's commodity sheds or some kind of shelter where if we're grinding hay or having commodities delivered into, putting some kind of cover or a curtain in front of them to keep rain out of them is going to do a lot in terms of reducing the amount of variation, giving us one less thing to try to monitor. One of the conclusions Dr. DiCostanzo had made in his group was that by trying to sample every day, that they introduced an additional source of error in terms of sampling error, analysis error, and they really weren't able to control the variation as much as they would have liked. So doing some things to prevent it in the first place might be more beneficial than trying to really tightly measure it. Last couple slides before we get to the conclusion. Finally, communication challenges. Human error is just all too common, whether that's due to lack of communication or the effect of Friday nights and Saturday mornings, or what we talk about sometimes in the northern plains about having corn planter or corn combine disease in an integrated system where we've got lots of things to do. All too often we have some challenges with the human element in implementing our plan. So what we want to do is we want to make sure everyone's on the same page, whether all the way from the nutritionist, the manager, the bunk reader, the cattle feeder, whether that's one person or several on your team, making sure everyone's communicating well. One of the points that one of our folks that work with one of our feed companies wanted to make sure I mentioned was, are you actually using and reading the batch sheets? They said too often they find some of their customers, the batch sheets are right where the nutritionist left them, even though perhaps some feed ingredients have changed. Maybe we've switched from high moisture corn to dry corn, which would dramatically change what we're doing in terms of feed deliveries. And finally, if we're using feed grade antibiotics, in the last few years, we've had to deal with veterinary feed directive. So we want to make sure that the veterinarian is also in the loop and that all the next necessary documentation's in place. Well, now I'm going to put on my crystal ball, or I'm struggling to find the right word, but the person that reads into the future, and why I think this topic could be more important down the road. And that's that interaction between bunk management and corn co-products. At least in the areas where corn co-products are widely available, it has made bunk management so much simpler compared to when what we were dealing with was dry rolled corn, dry or liquid supplement, and a roughage source. First off, we reduced the amount of starch we were feeding, which reduced the acidosis risk. The wet and the modified products did wonders in terms of improving mix integrity, and they also tended to enhance feed intake. But in the last few years, we've been dealing with and seeing some changes in the corn processing industry that I don't think are going to go away. First thing, the product itself has changed. First we took the oil out. Now the plants are looking at doing some fiber separation and diverting some of the products into a higher protein market that, in their case, is a higher margin, but leaves us with in the beef industry with a different product than what we've used before. Plus, and I think, if we only have to look at the events of this spring to start considering, can we count on distillers always being available at the snap of the fingers? What happened? An ethanol plant. We've certainly done our part to make sure that their feed co-product is in demand and that there's a market for it. Their ethanol on the ethanol side, they've had some challenges. So I think one of the things that we need to And my crystal ball is pretty dim and doesn't work all that well most of the time. But I think one thing that should be in our decision making process, or at least in the back of our mind, is what happens with the work from home trend and or electric vehicles across the Western economies, what that might do to fuel demand, and consequently what that might do to corn co-products. And if that's correct, and if they are less available or more expensive, some of the things we've been talking about with bunk management are going to be even more important than they are now. So to wrap up, in conclusion, bunk management is just as much art as science, but we can use the science to at least guide our decisions and make good decisions and and do the right thing for the livestock under our care. In my view, implementing a disciplined system allows us to more closely control variation, reduces our risk of serious mistakes, and builds resiliency into the system that allows the animal some opportunity to adapt when things don't go exactly as we like. And consequently, we need to think about this as an entire process and where those errors or variability might occur. We titled this bunk management, but I hope you'd agree that this topic encompasses quite a bit more than that. With that, that will conclude my part of the presentation. So again, thank all of you for being here with us, and we'll now open up the chat room and Q&A for anyone that has any questions.
Warren, there aren't any questions in the Q&A, but there is a question at the bottom of the chat.
Okay, I'm pulling this up. If I had a heat wave that dropped the feed intake for a whole week, should I have a heat stress diet to bring the animal back to the intake of the previous heat wave? I mean, change the diet. That's a great question. And, if there, I know we've got some other folks on here that might be able to weigh in. I think that depends a bit on what other feedstuffs you have available. One of the options that I think would make a lot of sense would be, perhaps before even the heat wave, adding fat or tallow to the diet. That's a bit of a scale dependent management choice. For some of the farmer feeders here in the Northern Plains, that isn't really a great option, where for some of the larger scaled operations, they can do that more easily. But the roughage part of that would be more apt to create heat. However, I think pulling more roughage out of the diet might do more harm than good from a rumen health standpoint. So you've hit a topic really well. Zach, I see he made a comment. Repeat the question. And I'll paraphrase as quickly as I can, but what's the applicability of having a heat stress diet? Something that could happen that we could use as we're trying to recover feed intake. The other question: what is best to feed once or twice a day? Okay, that's one I didn't address because I thought I might run out short on time. The best answer I've heard from that has been, what can you manage in your operation? Intuitively, one would say feeding more often is better for the animal in terms of more frequent feed deliveries, more consistent nutrient flows, and so forth. It also provides some real opportunities in terms of we can shift feed deliveries based on heat. The magnitude of a mistake is less if we can feed more than once. The other part of the reality is, though, for some operations, feeding twice a day poses some labor challenges, particularly for the feeders that I work with here in South Dakota, where we may also have a cow herd, we may also have a row crop or small grain or hay enterprises, and we're doing lots of different things. And those are some challenges that where a 2-a-day feeding just is harder to implement. And so maybe the best advice I've heard someone give to their customers was, tell me what you can accomplish well and do that. And that they would rather have them do once a day really, really well, rather than try to do 2 a day and have it not work. Dr. Pritchard had done some research here with multiple feeding times, and there was a little bit of slight advantages to multiple days, but it wasn't as overwhelming as perhaps some would like to tell people it would be. We worked with some of the heat stress supplements like essential oils. I have not worked with those a great deal. I've heard, anecdotally, and this sort of follows along with the feeding peppers. There's some evidence that they help, and excuse me, that to me is a combination, a question to discuss with the nutritionist as to whether incorporating those might work. I look at them. It depends on the devil's in the details. How much are they going to cost? And if the cost is minimal, I think that's something that's worth considering. That said, when it gets you know 95 degrees, 80% humidity, and no air movement, things don't do real well. Gonna trying to do these in order. Do we change the way we manage bunks from outside lots to confinement barns? Um, perhaps in a perhaps in an inside barn, if the heat stress is not as apparent, we may be able to be just a bit more aggressive. That said, again, I had calls just a couple weeks ago from people with cattle in barns that were dealing with some heat stress and reduced feed intake. So it helps, but it isn't necessarily a cure-all, and it doesn't let us just say, well, we can be much more aggressive just as an automatic answer. I think it really depends on reading the cattle in, kind of like that exercise where perhaps in that case where the outside lots, maybe we definitely need to pull back, where the inside lots, it's a little more of an open question. Reading bunks at night. Um, I know in some research facilities or some places they possibly do that. Um, my opinion is, I think I would rather do once a day. Is thinking of the strategy of what does our daily intake look like, because and allowing cattle to shift feed intake as their metabolic system tells them they should. But again, it's certainly not something that's going to do any harm. When corn is cheap, do we crack or do we feed whole? Again, that's another question that you know it, it seems like intuitively we should automatically crack. The research data is not is not as clear cut. One of the things that with one of the things that happens with whole corn is there is a slower digestion. Um, uh, does allow for less acidosis risk. That said, we have less starch digestibility. So from a performance standpoint, we lose a bit. So the other part of that question is, what is your cost to process corn? How fast can those feed time changes be made? So I'm not sure if you're meeting how frequently the bumps would be or how fast we might be able to shift feed deliveries. From a bump standpoint, I get really uncomfortable doing it more often than 3 times a day. I think, and I know people that do and get along wonderfully well with them, but I think that we are asking for some challenges as we go too quickly. From a feeding time standpoint, for some of these operations that shift feed deliveries due to heat, or plan on feeding more in the afternoon. I think we want to probably treat that maybe like we're doing a step up or an adaptation, where we're doing that over a 2 or 3 week period. But that's also a whole lot of a guess on that answer as well. Um, on young cattle that are weighing 300 to 400 pounds just off milk to prevent subacute acidosis, what would we recommend for a megacal change? They are at a 58, and then go to a 52. Can the calves get enough energy? That's a good question. I'm not sure right off the top of my head. I feel comfortable throwing my opinion out. I think though, considering all of the changes those cattle are doing, dealing with, that weight coming off of milk, they're very likely to be long haul cattle that perhaps coming off of a calf ranch. They're adapting to a different environment, uh, different feed stuffs. I would be and considering that these calves are going to be on feed for a very long period of time, I'd be really hesitant to go too high too fast, because I don't want to. I don't want to create too many problems on the front end. May depend too a bit on genetics in terms of, if these are, straight Holstein calves where we're worried about frame size, perhaps that changes the difference. Also, data about curb feeding, feed once a day and pushing it up to stimulate. Brian, I don't know of any data that says it does or doesn't. Um, However, it certainly would make some sense that it would. What should be the target intake percent of the target to start transitioning to the final diet? Target intake. Generally speaking, and if I am off, either Paul or Dr. Smith can correct me in the chat, but typically we're looking at starting cattle at about 2% of body weight, and then as we're going through our steps, that we're going to be usually a 3 or 4 steps to the final diet over approximately a 20 to 24 day period. The target intake isn't going to be a lot different than 2%, maybe 2.1 or so as we make that transition. Then once we get to the target intake, then we start increasing. One thing we don't want to do is raise intake and increase energy and density at the same time. So I get 800-pound steers. How fast should we push one to the finished diet? What we do here on research cattle that we're bringing in that are weighing 900 pounds or so as a start is we take 19 to 21 days to get them up to the final diet. Yeah, any more aggressive than that, I think I know certainly probably some people do. As soon as I say we shouldn't, someone's going to say we're doing it in 14. But I do think, again, it's back to that balance standpoint. How aggressive do you want to get, and how close to the edge do you want to ride? I think for the most part, that 21 days is probably, um, you know, going a lot less than that. I'd be a little hesitant. Anything else? Looks like we are right at 1 hour, so our timing is working out really well. But I'll stick around as long, Lindsay, as long as the link is live to answer any other questions. Seeing none, I think we'll wrap things up. Again, really appreciate everyone being here and their attentiveness, and really thrilled with the participation. Join us next week. Side note, I saw briefly in the chat there's some questions on whether this is recorded. Yes, it is, and it'll be available as soon as we have the final video up and ready ready to be released, and everyone will get an email to that. Beyond that, Lindsay has just shared my contact information for an email. Beyond that, join us next week. Dr. Eric Lowe with Midwest PMS is going to be talking about facility management. He's done an extensive amount of work in both in outside yards, but also slat barns and bed pack barns. So some of the questions we had today regarding feed deliveries, he may be able to address. With that, I will stay on for just a few more minutes, but thank everyone, and we will see you next week.